This is question 6 on January 23, paper 1 from Edexcel, from the international paper. So you have a figure that shows the design for a stage is a sector here, and we have two triangles. Be careful because they are not sectors, and this length is not the same as this one. They are two triangles and a sector. We know the angle BOC is 2.4 radians. This angle here is 2.4 radians. Area of sector BOC is 40, so we know the area of the big one. A of the straight line is 12.5 meters, so this length is 12.5 meters. Find the radius of the sector, giving your answer in meters into decimal places. So we have to find this radius here, which is not the same as this. We know the area, so we are going to use that. The area, remember, of a sector when you have radians is 1/2 r squared theta. We know the angle, we know the area, so we can find the radius. So for A, the area is 40, is given here, so 40 is going to be 1/2 radius squared is what I need. Theta is 2.4. And from here, I find radius. So radius is going to be 80 divided by 2.4 and the square root of that, which is 5.773 something else. We have to round to two decimal places. So this is going to be 5.77 meters. Remember to write units when you have them. When you have them in the question, yeah? B, find the size of the angle AOB in radians to two decimal places. So now we need AOB, this angle here. Let's going to call it alpha, for example. We know, what do we know about this? We know that this is a straight line. So if this is a straight line, the whole angle is going to be pi. So pi minus 2.4 is going to be these two angles together. So each of them will be half of that. So alpha, we can say, is pi minus 2.4 to have the two small angles and then divide by 2. And we can lift, no, it says round to something, no? Round in radians to two decimal places. So we divide with the calculator and we get to two decimal places, 0.37. Hence, find the total area of the stage, giving your answer in meters squared to one decimal place. We know the area already of this bit is 40, so we need to find the area of these triangles. We know the angle and we know one side and two sides because we know the radius. So we know this side, and the angle. So to find the area, we can do the formula of the area. So 1/2 of this side times this side sine of this angle. Yeah, that's what we are going to do. For C, the area of the little triangle or the triangle is going to be 1/2 times one side is half of this length, so 6.25. 6.25 times the radius that we found, which is this one. But before rounding, I would recommend you, instead of using the round one, the actual value, which is square root of 40 divided by 2.4. Yeah, so whatever that is, we say is 40, square root of 40 divided by 2.4. Yeah, the sine of the angle, and sine of the angle, again, calculator in radians because we are working with radians. I wouldn't write the 0.37 in the calculator. I would write the actual value and you round at the end, yeah, because if not, you're going to get some differences with their answer. And this is 6.5377 something. Keep that number in the calculator, and then the area, the total area, is going to be 2 times the area of the triangle plus the area of the sector. Yeah, so we have two of these triangles plus the sector, so it's going to be 2 times the 6.5377 something plus 40, and this is 53.075. And we have to round to one decimal place. So our area, the total area, is going to be 53.1 meters squared. Yeah. If you have round these values and you have used the 5.77 and 0.37 here, you're going to get a slightly different value that they have in the mark scheme. There is always some acceptance on slightly different values because of the rounding, but my recommendation is that when you reuse a value that you have found before and rounded, you use the actual value in the calculator, not the rounded one, just to avoid that. Yeah. And to avoid missing marks, just in case they take marks off for that. The total perimeter of the stage, given your answer in meters to 1 decimal place. So we are going to add all the sides. So this length is going to be 12.5. So the total perimeter is 12.5. And then let's say we have 2 of these sides and we don't know them. So we know this side, and this angle, but not this one. So it's a normal triangle. What I'm going to use to find this side AB is use the cosine rule, for example. So AB, so this will be 2 times AB. And let me finish before we find that. And then the last bit is the arc of the sector. And the arc of the sector is going to be, remember the arc of the sector, the length of the arc is r theta when we have radians. So the radius is the 5.77 that we found before times theta. And the 5.77 is not really 5.77, so again I could use the actual value in the calculator, the 80 or the square root of 80. So the length of the arc is going to be the root 40 divided by 2.4 times the 2.4, which is the angle. Yeah, so this is the 5.77 that you had. And let's going to find AB first. So I'm going to find AB using cosine rule. So AB squared is going to be the other 2 sides that I know. So this one is 6.25 squared plus the other one is the 4.77 squared. So is this value squared, so 40 divided by 2.4. You don't have to write this every time. Maybe you can put the value in the calculator in the memory and use it. Yeah, and just reminding you that I don't want to use the rounded values. Minus 2 times 6.25 times root of 40 divided by 2.4, just using cosine rule. Cosine of 0.37, which is not really 0.27, is this angle here. This one. Yeah, so that's what you're going to put in the calculator. Pi minus 2.4 cos of pi minus 2.4 divided by 2. And from here you find that AB is 2.26, and the perimeter, if we substitute here in the formula that we have, is 12.5 plus 2 times 2.26 plus root 40 divided by 2.4 and times by 2.4. This is going to be 30.9 meters to 1 decimal place. That's what they asked me to round. Yeah, but again, if you keep rounding all the values on your way, this value is going to be slightly different, even to 1 decimal place. Yeah, so just be careful with that. And that's all with this question.